Why can a submarine look like a smooth steel tube, yet still need a special hull just to survive going deeper? Because down there, the ocean doesn't just push. It crushes from every direction all at once. Here's the simple answer. A submarine needs a pressure hull because the crew must live at near normal air pressure, while the water outside becomes insanely high pressure with depth. Think of an empty soda can. It feels strong until you squeeze it the right way and it suddenly crumples. A pressure hull is built to prevent that kind of collapse by using the right shape, the right structure, and the right material. Water pressure climbs much faster than most people imagine. At sea level, you already have about 1 atmosphere of air pressure on you. Go down roughly 10 meters, and the water adds about another atmosphere. At 100 meters, the sub's hull is seeing around 11 atmospheres total pressure. At 300 meters, it's around 31 atmospheres. And that pressure doesn't push from one side, it pushes uniformly, squeezing inward everywhere. The basic idea is captured by the physics relationship P equals rho gh, density times gravity times depth. Depth is the killer. Double the depth, and you roughly double the pressure. This is why submarines are often built like a vehicle wrapped around a pressure vessel. The outside of a submarine might include a streamlined outer casing, sonar domes, and ballast tanks, parts that help with movement and buoyancy. But the pressure hull is the true survival capsule. Inside that hull, the crew needs a breathable environment, roughly the pressure you feel on the surface, so the inside can't be allowed to compress. That means the pressure hull must resist a huge inward load while keeping its shape, its seals, and its joints intact. If you remember one design rule, make it this: curves survive pressure, corners concentrate failure. A cylinder and a sphere spread forces smoothly. The stress flows around the surface like traffic on a circular highway. But a box shape? Bad idea. Flat panels bend. Edges become stress concentrators. Under external pressure, those flat surfaces want to buckle inward like a metal ruler snapping. That's why pressure hulls are usually cylindrical, sometimes with multiple cylinders connected, and why the ends are often domed or hemispherical. A sphere is even better for pressure, but it wastes space for long vehicles, so submarines use the best compromise: long cylinders with strong end caps. People assume the hull fails because the metal isn't strong enough. Sometimes it's not about the metal yielding like bending a paperclip. More often, the danger is buckling, a sudden instability. Buckling starts with a tiny dent or imperfection. Under pressure, that small dent changes the force paths, and the structure can give up abruptly. It's the same reason a fin can hold weight, until one little dimple appears, and then it collapses fast. To fight buckling, submarines use thick hull plating, plus internal structure, ring frames, stiffeners, and bulkheads that keep the cylinder from ovalizing. Engineers aren't just making the hull strong, they're making it stable. Now the brutal trade-off: deeper means heavier, and heavier means harder to move, harder to float, and more expensive to build. Pressure hulls typically use high-strength steels, and in some designs, titanium alloys. But material choice is only half the story. Welding quality, heat treatment, inspection, and fatigue life matter because a submarine hull experiences repeated pressure cycles over years. And depth ratings are conservative for a reason. Navies often talk about concepts like test depth versus design limits because they build in safety margins against manufacturing imperfections, corrosion, and long-term fatigue. Also notice something: submarines don't have big square windows. Openings are weak points, so hatches, penetrations, and viewports are minimized, reinforced, and carefully shaped. Every hole is basically the hull asking permission to remain strong. So submarines need pressure hulls because the ocean's pressure increases relentlessly with depth, and surviving that isn't just about thick metal. It's about shape, stability, and engineering margins, a controlled battle against buckling.